Okay, trying to excuse me, get things kind of combobulated here in the background. All right. We're on YouTube. Okay. Well, welcome to another episode of our show. This is going to be kind of an interesting one and a rambly one because I'm trying to figure out a way to explain a kind of complex set of issues that I ran headfirst into working on GajuExpress. So, I need to post these links elsewhere also. Okay. I'm putting links out. That's what I'm doing. To this stream. Let's see. Donk. It always takes a few minutes for people to even figure out that the stream's on anyway, so it's not like we're losing a lot of time. Okay. So, in the course of writing GajuExpress, we have the classic situation where a client looks for a service backend, probably by domain name. It says, hey, I want to make a connection to whatever domain name and then port number and so on. That's of course what you do between computers. But then you want to authenticate the service. Okay, so how do I know for sure that I'm really talking to the actual GajuExpress and not somebody who's impersonating GajuExpress? Well, this gets into the classic, sort of TLS certificate thing, where you would have a certificate authority like VeriSign or DigiCert or somebody, or Let's Encrypt, whatever, and you would set up a TLS tunnel, and that would be, you would have a certificate authority that you trust, and they're vouching for the certificate that the service endpoint's got. And if all the signatures check out, you go, okay, that must be the service I want to talk to. And what you're really verifying is, does the domain name point to the real service I'm looking for? And it's only a name verification. Actually, it's not really a verification of the service. It's a verification of whether the holder of the name is the one that was able to get a verified signature, to you. Okay. Well, then there's another issue, which is I would like to not have the metadata leak of the public key of anybody posting a thing on GajuExpress. I'd rather keep, it's not that the public key's not public, it is, but you want to keep that private too, if possible, because it's an identity. It's a public identity in some sense, in the cryptographic sense, but it may not be a public identity in like the social sense, for example. Okay, so now those could be ephemeral, but they may be tied to a more significant real identity as well. So how do we keep that secret? Well, we would want to establish a tunnel with the service endpoint, and then convey the public key data, that type thing. Now that becomes more significant when it comes to lookup of I want to look up what files are waiting for me. Anyway, thinking through this, that first step, I want to communicate with server X that's at domain name whatever. So GajuExpress.com or whatever it is. Okay, well, I trust that DNS is going to give me, that a DNS query is going to give me back the correct IP address to connect to, right? And if it doesn't, that would be, a denial of service attack vector. If I was able to corrupt DNS in some way, I couldn't usurp or imitate GajuExpress, but I could prevent people from talking to GajuExpress if I just were to scramble up the IP address. So why am I trusting DNS? It's a distributed it's actually literally a distributed ledger problem, right? That you want to have a simplified name that humans can remember. You know, they want to know yahoo.com. They don't remember the IP address list that is yahoo.com servers. So DNS solves that for us. But DNS solved that for us in a very kind of archaic first attempt sort of way of doing a distributed ledger. And it was never very secure. It depended a lot on the fact that the early internet was really the ARPANET, and kind of like email. Email's still not secure at all, because of this legacy of like where it came from when it didn't need to be in a secured, you know, security was an afterthought, basically. The fact we could get two computers to communicate at all was like this amazing idea. So if we backtrack and look at the foundations of how we're connecting, we're trusting DNS and we're pretending that DNS can be secured, which it really can't. We're also kind of trusting that DNS is decentralized, which it's actually not today in practice. Yes, your ISP provides a DNS endpoint for you. Yes, you can make sure that your computer uses that or whatever, but almost every mobile lookup goes through Google, and almost every desktop lookup also goes through Google if it comes from a browser. And that's because Google sponsors all the browsers, and they do that so that they can get their DNS worked in to it. And DNS doesn't happen as DNS is defined anymore. DNS happens over normally happens over UDP. Now DNS happens over HTTPS, which leads us to this other issue, which is HTTPS. The S part, the TLS part, goes back to the CA thing, and I said that we trust the CA. So there's a lot of implicit trust going on already. And the whole like framing behind blockchain is trustlessness. It's kind of interesting that we have this in the context of a trustless project like Gajumaru, where Groot has to be proof of work because we can't figure out a way that's better than proof of work to solve the trust problem. In the context of that, I realized, hey, we can do this cool thing that's like secure file sharing, and it can be paid, and you can wrap all this up with a nice bow on it, and verified IDs and all this cool stuff. It's really neat that we can do this backed by a blockchain and paid for by a blockchain and verified by blockchain IDs. That's really neat. So that was the origin of the idea for GajuExpress. But as I'm writing it, I run into this thing like, well, why am I trusting DNS as a lookup thing at all if the whole point's trustlessness? It's kind of weird. It goes back to this OPSS network thing that I had written up as a response for Larry Sanger when he was asking, like, what's a thing that could replace, centralized social media? And all kinds of people had silly ideas about, like, we'll do everything on the blockchain, and like, no, you won't. You're not going to put social media on the blockchain. You might pay for social media on a blockchain, or as we've discovered where we're at in another area, you can use something like Capillary on Gajumaru to do micropayments for, at the kind of speed and scale that you would want for paying for social media posts. But you're not going to put a social media site, an application, and everything into a blockchain. That's a mistaken idea. And browser plugins aren't good enough for any of this stuff. You don't want your private keys anywhere close to a browser plugin. I still can't believe MetaMask is real. It's that bad. So all that, so it's supposed to be trustless, and then you use a thing that's delivered by NPM, which is centralized. Like, it's all silly. So how do you get back to the beginning of all this? And that first connection, I want to use GajuExpress. Well, how do I resolve GajuExpress? That resolution step of figuring out, translating that name, GajuExpress, to an IP address. Now, the name could be kind of anything. The IP address, I need to make sure that I can change that in the future. So I need to have a reference that can point to an arbitrary changeable reference. Okay. Well, what's a thing I can use that's decentralized, trustless, and can provide a lookup to usefully resolve an IP address, and not just IP address, but give me a way to verify the service itself also, the TLS-CA problem. How can I do that? So the CA problem is really sticky because certificate authorities, there's like dozens, maybe hundreds of them. You have them all pre-installed on your computer, pre-installed in your browsers also. They come with their own bundles often because different operating systems are like missing one or another of them, and the user like never sees them. They just see the lock icon or the check icon or the shield icon. HTTPS, yeah, this is secure, thumbs up. Well, the certificate authority, the problem with certificate authorities is that to load one website, like you go on Discord, right, and you use the app or whatever, or you go to like a news website, you open the New York Post or whatever, and you're making hundreds of web requests for all these different components that are on the page and all these things that you don't see that are on the page that are there, which is all the framework stuff to make anything work. All those components have to get loaded, and it's hundreds of requests, very often to hundreds of different domain names. So that's different domain lookups, lots of them. So you're trusting DNS quite a lot now, which means you're trusting Google almost entirely, because that's usually where you're doing all your lookups at. Which also means that, well, the reason Google provides that for free is not because they're friendly. They do it because that gives them all the metadata about all of your activities. They know every domain that you're looking up at very high volume. So you're trusting them to give you the accurate DNS data, that they're not misleading you. And the certificate, that's all those connections are HTTPS. So every site that you hit, they send back a certificate, and they verify them, they authenticate themselves to you with the CA system. Now, because it's such a huge volume of requests, it would not be feasible for a user to get a notification from the browser every time a new certificate authority was being checked. So those hundreds of requests, it'd be hundreds of pop-ups like, do you trust this authority? Do you trust this? Do you trust? And you'd be like, I guess so. Yes, all. There's no way you could open a website. So the default is you just trust all the CAs. You just implicitly trust that the CA, the certificate authority bundle that you have, is completely like trustworthy and true, and that there's nothing bad in there at all. Okay, that's kind of like we're doing a trustless project for money with the Gajumaru, right? Trustless money. Well, then everything we do on like web, especially web stuff, is fully trustful. We absolutely trust the certificate authorities. We absolutely trust DNS. We also trust BGP and a couple other things, and we don't have to get into those. There's a bunch of like connect the dots details about how traffic shaping plays into this and all that. But the basic point is that because you're not verifying each CA as you go, if any one CA is compromised, they're all as good as compromised. That's how the certificate authority system works. So imagine after what we've lived through the last several years, imagine believing that the certificate authority bundle is full of like dozens or hundreds of certificate authorities, and that not a single one of them is compromised by an outside attacker, some crack that got into their system, government coercion, organized crime, Chinese spies, whatever, that absolutely zero of them are compromised. That seems insane, right? That's a crazy thing to believe. And second to that, given how centralized DNS is, it's used as a censorship vector all the time. We block lookups with DNS constantly. What is it? Sci-Hub, I think. SCI-HUB. Those domains are blocked all the time by ISPs, by government fiat, like you have to block this domain name. Google blocks them, I believe. So they like travel around, finding different places that they can try to have a name, so people can access scientific literature that they've hoovered up. So that's weird. There's like this censorship function that is deeply in effect all over the place. And then you've got the tunnel problem that the CA authorities, if any one of them is compromised, then they're all effectively compromised. And the chances that zero of them are compromised is close to zero. You have, A sufficiently well-connected attacker will find that the HTTPS web is completely transparent to them. And all traffic can be shaped and rerouted through their man-in-the-middle attack things. Hello, Cloudflare. And that's this completely transparent world that the entire web world has been convinced to not question and just accept and go along with. That's kind of insane. So do we have anything that could be decentralized and fix that problem? Because you always have the problem with networks. There's this thing called the initial reference problem. The initial reference problem is the problem that if you have like a large peer system and it's all peer and the peers share addresses of other peers and all that, you have to start with one somewhere to get your like seed list. So what most peer networks do is they have like a canonical set of node references somewhere that they kind of seed the population with. So like Nutella worked that way, or maybe still works that way. Freenet is called Freenet, Tor, IPFS, all those type peer networks. They have a seed list of addresses, and they're just raw addresses. And you try to connect to all of them, and any one of them that responds can give you further addresses. And so now you can kind of crawl across the network and get a large cache of addresses that are current, and you have to build out your view. But that first reference, if you can't find a single one of those in that initial list, then you're stuck. You don't know where anything is. So the way DNS solves this is there's a seed list of canonical domain authorities, and you make requests to those to get a list of names, and you kind of like, well, it's a chain of like sort of proxied requests across DNS to get name resolution, and they cache all the way down to you. That was the innovation of DNS in the first place, was to get this kind of tree of trees that cache data for a certain amount of time so that it could be mostly distributed, and solve the initial reference problem at the top somewhere and then kind of trickle down. So the initial reference problem, it has to be solved somehow. And the way we've solved it globally so far with networks is the domain name system. And it's not terrible, but it's not really securable. We have DNSSEC and IPsec and whatever, and all those have holes in them. Holes which they were frustrating they were exploitable, but annoying to exploit in the past. Now you could, agentic automation would make subversion of the DNS system much, much smoother today from the attacker's perspective. Mixed together with, everything came out from the Snowden leaks. It's like traffic shaping is that's something that people do every day. And you can play with the BGP tables, and you can make an IP address appear to be in a couple different places at once. And the one you connected to might not be the real one. The certificate authority, if they're evil, then, if they're a sneaky certificate authority that's compromised, may have set up a man-in-the-middle attack. You don't know. Everything's just, again, to a sufficiently well-connected attacker, the entire web, the entire TLS system is totally transparent. It's all plain text for them. Now, the reason that this doesn't result in your bank account instantly getting drained is because, you log into your bank account and 2 seconds later you have no money. The reason that doesn't happen is that the people who have that authority and that attackers who are that well connected, they have no interest in petty crime. They own the money printer. They own the money printer that blockchain was designed to defend against, right? So it seems kind of inevitable that if we're going to make decentralized money work, if blockchain is going to solve the money problem, the trust function that proof of work provides to protect money also has to protect the solution to the initial reference problem. And everything I said sounds like it could be a technically deep and nerdy, difficult to implement thing. It might be hard to get that done. And I would argue maybe not. Maybe we could come up with a solution that's relatively lightweight, fairly flexible, and we could standardize it, and it's self-served and self-sovereign. So this would be sort of a self-sovereign. I just don't like the phrase, because sovereign is sovereign, self is self. They should be the same. So a self-signed way of like first party, not third party verification of a service, but first party verification of a service. That should be possible. And I believe it is. And I think I've got some idea how we might go about doing this. And I would like to use it as the resolution, like the address resolution method for GajuExpress, so that we have a good platform to play with the idea and implement it once and see how it feels and so on. So what we're going to try today is to replace DNS and TLS and, we're going to try to solve the initial reference problem, and we're going to do service verification without depending on any centralized system whatsoever. We're going to do everything in a decentralized, trustless way. And if we can get to that point, then we can use this trustless utility to verify a trustful service. And then we're really cooking with gas, because we get away from, we don't need DNS anymore. We don't need we need something that tunnels like TLS, right? But we don't need the TLS certificate authority regime, which is absolutely scary. If we think carefully about how DNS and TLS and the TLS thing works, like, it's pretty scary. It's also scary that like SSH is all self-signed, right? SSH